Alright, let's look at the gradients. Let's say you have a function of multiple variables, say f of x comma y comma z, so it depends on three variables. Alright, then we're going to look at the gradient. Right, so as you remember from Calc 3, it's defined as a partial derivative of f with respect to x is the first component, and a partial derivative of f with respect to y is the second component, and a partial derivative with respect to z is the third component. So this is going to be a vector, and if you remember from physics or Calc 3, and this represents basically the direction of the most increase of the function value. So if you were to increase the value of the function, you would want to move in the direction of the gradient, right? So for example, let's look at the temperature function. So let's say you have a hot plate, so on an xy plane, then we put the blue line for where temperature is equal to 0, right? The green curve for temperature equaling 5, and the red one for temperature equaling 10, right? And if you're, say, standing on the hot plate, and let's start from somewhere around here, right? So let's say you're here, right? Then you want to get the most increase in temperature, right? So as you can see that it doesn't make sense to move in this direction, move in the tangent direction of the kind of an isothermal curve, because that way the temperature is going to basically stays the same, right? So you want to do completely the opposite of that. So what we want to do is you want to go perpendicular to that tangent line. So you have, this is going to be the direction that you would want to have. So in the same way, and if you are at this point, and probably the direction you want to head toward would be that direction, right? So if you want to take a path and you're going to start from here, then what you want to do is move along this direction and here, and then try to get hotter and hotter, right? But this direction is given by the gradient. So if you find the gradient of this temperature function, that's the direction we get from the gradient, right? So you can see that the gradient is always perpendicular to the isothermal curve. So here maybe I should say gradient of t is perpendicular to the isothermal curve. So x comma y equal to some kind of constant there, right? In a three-dimensional case, it is the same. So let's say you have a surface of written as f of x comma y comma z equals c, where c is a constant. Then that's going to form some kind of a surface in three-dimensional space. So I drew it in purple here, right? Then if you find the gradient of this function f, it's going to be basically the normal vector. So let's say you pick a point maybe somewhere around here, right? And it looks like normal direction is this direction, so it's perpendicular to the surface, right? And this normal direction can be found by taking the gradient of this function f. Because again, think of it as the direction of most increase. This purple surface is going to be isothermal if it was temperature, where the function or temperature doesn't change. So if you want to get the most increase in temperature or function value, you would want to go perpendicular to that surface. So the gradient is going to give you that direction. All right, that's it. I hope that this was clear.